Okay, let's dive into a question that seems super simple on the surface. But trust me, the answer is going to take us on a wild ride into some of these strangest corners of physics. It all kicks off with a question you've probably wondered about yourself. So what's the deal? Are they? It makes sense to ask this. We know that things like radio waves, microwaves, even X-rays, they're all just different flavors of light on the electromagnetic spectrum. So it seems totally logical that sound would just be another stop on that same line, right? Well, the truth is way more fascinating. To really get to the bottom of this, we've got to go back to basics. See, sound and light aren't just different frequencies of one thing. They are two completely different types of waves.
And here is the absolute key difference. Sound is what we call a mechanical wave. Think of it like a shock wave or a line of dominoes falling over. It needs stuff to travel through. It has to physically shove molecules of air or water or whatever out of the way to move. Light, though, that's an electromagnetic wave. It's this incredible, self-propagating dance of electric and magnetic fields, and it doesn't need any medium at all. It just goes.
Yeah, this quote from a discussion online just nails it. Sound waves are wobbles in the air itself. Light waves are wobbles of pure energy fields. You know what? A great way to picture a sound wave is to think of a slinky. When you push one end, that compression wave travels all the way down the coil. That's what sound is doing to the air around you. So this one huge difference, needing something to travel through versus not needing anything, has an absolutely massive consequence. And to see it in action, all you have to do is look up into space. This really is the fundamental line in the sand. Light from a star billions of light years away can travel across the unimaginable emptiness of space to reach our eyes. But sound? Sound can't even make it 1 inch in a vacuum. Without matter to push, it simply can't exist. And this is just the best way to remember it. Next time you're watching a movie and see a massive spaceship explode with a huge booming sound in the dead of space, you can just smile, because you know that in reality, it would be completely and utterly silent. It looks cool for sure, but it's just not how physics works. Okay, so sound is mechanical, light is electromagnetic. They're totally different things, live in different worlds, case closed, right? Well, this is where things get really, really cool. Is it possible for these two completely separate phenomena to actually interact? We've just established they play by different rules, but can one actually influence the other? Incredibly, the answer is yes. The secret to how this happens is a principle called diffraction. Now, that might sound fancy, but it's something you experience every single day. It's just the natural tendency of a wave to bend and spread out when it hits an obstacle. It's the reason you can hear someone talking in the next room even when you can't see them. The sound waves are literally bending around the doorway. Now, take a look at this diagram. It's from a real Stanford experiment, and it shows this idea in action. Imagine you shoot a powerful sound wave through water. That sound wave creates these invisible ripples, areas of high and low pressure. Well, if you then shine a laser beam through those ripples, the light treats them like a physical barrier. That sound wave barrier literally forces the beam of light to bend and change its path. And there you have it. It's just mind-blowing. Under the right setup, a mechanical wave, sound, can create a physical structure that literally steers an electromagnetic wave, light. The two separate worlds are actually colliding. Okay, that is already pretty wild. But let's take one final jump off the deep end into some truly cutting-edge physics. We're going from sound-bending light in a normal substance like water to something that can happen to light all by itself inside a really exotic material. The idea is called additional light waves, or ALWs for short. Let me try to put this simply. It's a phenomenon where you take a single particle of light, just one photon, and you fire it into a very special type of crystal, and what comes out the other side is more than one distinct wave of light. And get this isn't just a crazy theory. As the researchers state right here, this bizarre picture has actually been observed in experiments. This is real stuff that's happening in labs right now. So how on earth does that even work? Well, it's kind of a three-step process. First, that single light wave goes into this special crystal. Then it interacts with a weird property of the crystal. You can basically think of it like the crystal sort of splits the light, sending it down multiple paths at once based on its energy. And third, because of that complex interaction, multiple separate waves of light all emerge together at the end. So what we're really talking about here is an echo, but not an echo of sound bouncing off a canyon wall. Under these very specific, very strange conditions, a single ray of light goes in and it creates echoes of itself.
Think about that for a second. We started with a simple question, are sound and light the same thing? And we ended up with light that can literally have echoes. It just makes you wonder, if a single ray of light can pull off a trick like that, what other mind-bending secrets are waves hiding all around us, just waiting to be discovered?